I recently had the pleasure of speaking at an event about how additive manufacturing or 3D printing is changing the face of manufacturing and what that means for us as engineers. And in this video, I want to cover some of the topics we discussed there. I'm the founder of a company which helps engineers design better 3D printable parts. If you're new here, make sure you subscribe so you don't miss our weekly videos on 3D printing and other topics related to engineering design. The first thing I talked about was the traditional way of making parts. We start with a computer-aided design program like SolidWorks or AutoCAD. And we use that to create a part. From there, we export that part as a file that can be used by a computer numerical control machine or CNC machine. This is typically a milling machine that uses rotating cutters to remove material from a solid block of material like aluminum or steel. What you end up with is a very strong part that can be made to very tight tolerances. But there are some disadvantages to this process. First, you have to start with a block of material, which means that you cannot make the part hollow to save material, and this is a huge disadvantage. Material costs are one of the biggest costs of making parts. So it's not surprising that companies are always looking for ways to reduce the amount of material they use. Second, you're limited to the size of your material. If you want to make a large part, then you have to buy large, expensive material, and that increases your cost. And third, if you need to make changes to the part, you have to go back to step 1 and redesign the part because UKUNT isly modify the code that goes to the CNC machine. Now, let's take a look at how 3D printing changes all of this. With 3D printing, we still start with a CAD model, but now instead of exporting to a file that's used by a CNC machine, we export that part to a file format that can be used by a 3D printer. 3D printers use a process called fused deposition modeling, where plastic filament is deposited layer by layer to create the part. The advantage this offers over CNC machining is that you don't have to start with a block of material, which allows you to make the part hollow to save material. This is a big deal because it reduces the amount of material you need to buy and it reduces your cost. It also allows you to make larger parts without having to purchase expensive, oversized material. And if you need to make changes to the part, it's not a big deal because it's easy to modify the 3D model and then reprint the part. But these aren't the only advantages of 3D printing. There are more. You can make complex internal geometries that would be impossible to manufacture with conventional machining methods. This is because with 3D printing, each individual piece of material is linked together to all the other pieces of material through this lattice structure. So if you want to make a part with internal channels or other complex internal geometries, 3D printing makes that possible. Another advantage of 3D printing is that it gives you access to a wide range of materials that you wouldn't be able to get with CNC machining. This includes things like composites, ceramics, and even metals. Although metal 3D printing is more expensive than other processes like CNC machining, it offers the ability to make parts with detailed internal geometries that you just can't achieve with any other manufacturing method. So now you can see that 3D printing offers a number of advantages over CNC machining, but that doesn't mean it's a perfect solution. In fact, there are several significant disadvantages of 3D printing that we should talk about. One of the most significant disadvantages of 3D printing is that the surface finish tends to be rougher than what you'll get with CNC machines. This is because 3D printing is a layer-based process, and you can see the layers in the final part. Now, you can do things to improve the surface finish of 3D printed parts, but the surface finish will never be as smooth as what you can get with CNC machining. For applications where a smooth surface finish is important, 3D printing might not be the best option. Another disadvantage of 3D printing is that it can be slow. This is because the part is built up layer by layer, and each individual layer has to be linked together to all the others. This takes time and it can result in long lead times. If you're trying to build a prototype quickly, 3D printing might not be the best option. And finally, 3D printing can be expensive. Although the cost of 3D printers has come down significantly in recent years, they're still relatively expensive compared to CNC machines. Additionally, the cost of materials for 3D printing can be high, especially for metal 3D printing. If you're trying to produce parts in high volume, then 3D printing might not be the best option. So now you can see that each manufacturing method has its own advantages and disadvantages. There's no one-size-fits-all solution. It really depends on your application. However, I believe that 3D printing is an ideal prototyping tool. It allows you to quickly and easily make changes to your design and test them out in the real world. Once you've finalized your design, you can then move on to mass production using more economical methods like CNC machining. But this isn't the only reason why I think 3D printing is changing the face of manufacturing. I believe it's also changing the way engineers approach their work. In the past, engineers were typically trained in one discipline, such as mechanical engineering, electrical engineering, or civil engineering. However, many of the problems we face today require expertise from multiple disciplines. For example, consider the problem of designing a bridge. To design a bridge, you need expertise in civil engineering, mechanical engineering, and electrical engineering. Ideally, you would have engineers from each of these disciplines working together to solve the problem. However, in reality, this is often not the case. Civil engineers typically don't know enough about mechanical or electrical engineering to design a bridge that meets all the necessary requirements. As a result, we often end up with bridges that are over-engineered. They have features that are not absolutely necessary, but they're included just in case. Additive manufacturing or 3D printing is changing this because it allows engineers to quickly and easily prototype their designs. This means that engineers are no longer constrained by the limitations of their own knowledge. They can explore new ideas and concepts that they may not be familiar with, because they can quickly test them out and see if they work. This is leading to a new breed of engineers who are not constrained by their own knowledge, but instead are limited only by their imagination. One example of this is a project I worked on with a company which manufactures tents and shelters for the military and first responders. They came to me with a problem. They needed a way to attach guy lines to their tents. Guy lines are used to secure the tent to the ground and keep it from blowing away in the wind. The problem was that the standard way of attaching guy lines to tents was not working well. The lines were constantly coming loose and the tents were difficult to set up. My team and I worked with them to develop a new solution. We designed a 3D printed attachment system that allowed the guy lines to be quickly and easily attached to the tent. Once we had the 3D printed attachment system, we were able to work with the company to test it out in real-world conditions. The results were amazing. The new attachment system worked perfectly and the tents were much easier to set up. This is just one example of how 3D printing is changing the way engineers approach their work. As 3D printing technology continues to improve, I believe we will see more and more examples of this. So now you can see that 3D printing offers a number of advantages over traditional manufacturing methods. And it's also changing the way engineers approach their work. But what does this mean for us as engineers? It means that we need to be open to new ideas and new ways of doing things. We need to be willing to learn new skills and embrace new technologies. Additive manufacturing, or 3D printing, is one of those technologies that we need to embrace if we want to be successful engineers.